Quantum computing, stepping into a new dimension of computation. From landing rovers on Mars to running our entire global economy, modern computers are astonishing. They crunch billions of numbers in a blink. But what if I told you there are problems so vast, so incredibly complex, that even the most powerful supercomputer on Earth would take trillions of years to solve? What if, to unlock the next level of human progress, we need to step into a completely different dimension of computation? This isn't science fiction. It's quantum computing. A mind-bending leap that harnesses the universe's most mysterious rules that govern the tiniest particles, to solve problems once thought impossible. Welcome to the Smart Side, the channel where we unravel the ingenious science and hidden processes behind the everyday and the future. Today, we're diving into the strange, beautiful world of quantum computing, a frontier where physics meets possibility and the impossible starts to look a little more achievable. To truly grasp quantum computing, we first need to understand its predecessor, the classical computer you're watching this on. Every piece of information in a classical computer, from a single letter in your email to a complex video, is broken down into tiny units called bits. And a bit has only two states, 0 or 1. It's either on or it's off, like a simple light switch. To solve a problem, a classical computer has to go through every possible combination, one by one, flipping those switches in sequence. Imagine you have a locked safe with 1,000,000 combinations. Your computer tries one, then the next, until it finds the right one. It's incredibly fast, yes, but it's fundamentally a linear, step-by-step process. Think of it like a library. A classical computer reads one book at a time. Now, throw out everything you thought you knew about bits, because quantum computing introduces the qubit. This is where the universe's weird rules come into play. A qubit isn't just a 0 or a 1. Thanks to a quantum phenomenon called superposition, a qubit can be both 0 and 1 at the same time. And not just 0 and 1, but every possible value in between simultaneously. Imagine that spinning coin again. Before it lands, it's neither heads nor tails. It's in a state of superposition, a blend of all its possibilities. It's only when it finally lands, when you measure it, that it picks a definite state. Qubits behave like this. They can exist in a blur of multiple states all at once. This seemingly simple difference is profoundly powerful. But the magic of qubits doesn't stop there. Introduce quantum entanglement. This is even stranger. When two or more qubits become entangled, they become inextricably linked, no matter how far apart they are. Their fates are intertwined. Imagine you have two magical coins. You spin them both, then put one in a box and send it to the other side of the galaxy. The moment you look at your coin and it lands on heads, you instantly know the other coin, millions of light years away, has landed on tails, without ever seeing it. Show this instantaneous knowing. Emphasize the spooky action at a distance aspect. If you measure the state of one entangled qubit, you instantly know the state of its entangled partner, even if it's across the universe. It's like they're whispering secrets to each other across vast distances, without any apparent connection. This isn't communication, it's a deep shared quantum destiny. This entanglement is crucial because it allows qubits to work together in powerful ways, sharing information and performing complex calculations that classical bits simply cannot. So, you have qubits that can be 0 and 1 at the same time, superposition, and they can be mysteriously linked, entanglement. Combine these and you unlock the true power, quantum parallelism. Remember that safe with 1,000,000 combinations? A classical computer tries them one by one, but a quantum computer, thanks to superposition, can essentially exist in all 1,000,000 combinations at once. It explores every single path to the solution simultaneously. And entanglement allows these simultaneous paths to communicate and find the optimal solution much faster. This isn't just faster, it's an exponential leap. With just 300 qubits, you could store more information than there are atoms in the observable universe. Building these quantum machines is incredibly challenging. Qubits are fragile. They need to be cooled to temperatures colder than deep space and isolated from any outside interference. Even a tiny vibration or a stray electromagnetic wave can cause them to lose their quantum state, a phenomenon called decoherence. But despite these hurdles, astonishing progress is being made. Scientists and engineers are racing to build stable, error-corrected quantum computers that could unlock truly revolutionary capabilities, revolutionizing medicine, simulating complex molecules for new drugs or personalized treatments. designing new materials, creating ultra-efficient batteries, superconductors, or stronger materials. Breaking encryption, solving the toughest modern encryption codes, and simultaneously creating uncrackable quantum encryption. Supercharging AI, powering the next generation of artificial intelligence and machine learning. Optimizing everything, from supply chains to financial models, finding optimal solutions in vast data sets. So, quantum computing isn't about just making our current computers faster. It's about fundamentally changing how we approach problems, opening doors to discoveries and solutions that were once beyond our wildest imagination. From a single bit that's both on and off, to entangled quantum networks whispering secrets across the universe, we are stepping into a new era of computation. The quantum age is here, and its possibilities are truly limitless. What quantum possibilities excite or concern you the most? What other mind-bending scientific frontiers do you want us to unravel on the smart side? Share your thoughts and curious questions in the comments below. If you found this journey into quantum physics enlightening, smash that like button to support more smart content, share it with a friend who loves the future, and make sure to subscribe to the Smart Side for more mind-blowing discoveries. Stay smart, stay curious, and embrace the quantum.